Let's quickly have a conversation about virtual machines versus container. So, what's the big difference between containers and virtual machines this year? So, containers and virtual machines, if you think about it, are technologies that make your applications independent from your IT infrastructure resources. So, that's kind of cool in terms of data validation, but also cost allocation. So, a container is actually a software code package containing an application's code, its libraries, and other dependencies. So containerization makes your applications portable so that what happens here is that the same code can run on any device, any device. So that's for containers. A virtual machine is actually a digital copy of a physical machine. So you can have multiple virtual machines with their own individual operating systems running on the same host operating system. In addition, and that's a big one, you can create a virtual machine that contains everything required to run your application. So that's kind of cool. And containers and virtual machines are very similar resource virtualization technologies. In other words, if you think about virtualization, I want you to think about the process in which a system singular resource like RAM, CPU, disk, or networking can be virtualized and represented as multiple resources. So the key differentiator between containers and virtual machines is that virtual machines virtualize an entire machine down to the hardware layers, and containers only virtualize software layers above the operating system level. Okay. And I want you to really look on the screen here. Here is a representation of virtual machines and containers. And I want you to really look at it for a few seconds. That's important. You can see for virtual machines, you have the hypervisor and the infrastructure. For containers, you have the container engine, the host operating system, and then you also have the infrastructure. So, where are containers and virtual machines used this year? Let's talk about that. Well, containers and virtual machines are actually both deployment technologies. So, in the software development lifecycle, deployment is actually the mechanism that makes an application run efficiently on a server or device, and the application requires several additional software components called dependencies that are closely related to the underlying operating system of the server. And all these different software layers between the application code and the physical device are actually called the application environment. So you'll hear this term a lot, application environment. Let me go a little more granular here. I want to really go more granular in terms of the term container. So what is a container? So containers are actually, if you really were to visualize them, they are lightweight software packages that contain all the dependencies required to execute the contained software application. And this dependencies include things like system libraries, external third-party code packages, and other operating system level applications. And the dependencies actually included in a container exist in stack levels that are higher than the operating system. Okay, that's important to remember. So, what are the pros and cons of containers here? First, you have iteration speed, robust, and a robust ecosystem. Those are the top two pros I want you to think about. So, when you think about iteration speed, because containers are lightweight and only include high level software, they are very fast to modify and iterate on. You have a robust ecosystem, so most container runtime systems offer a hosted public repository of pre-made containers, and these container repositories contain many popular software applications like databases or messaging systems and can be instantly downloaded and executed, saving time really for development teams. So that's really important. So those are the pros. You also have the cons. So you do have shared host exploits. You have Docker. You have RKT. You have Linux containers, and you have also Creo or Cryo. So if you think about shared host exploits, containers all share the same underlying hardware system below the operating system layer, it is possible that actually an exploit in one container could break out of the container and affect the shared hardware. Most popular container runtimes have public repositories of pre-built containers, so there is a security actually a risk in using one of these public images because they may contain exploits or may be vulnerable to being hijacked by nefarious actors, by bad actors, by hackers, if you will. So Docker is actually the most widely and I mean the most popular and widely used container runtime. And Docker Hub is a giant public repository of popular containerized software applications. And so this could be a problem. Of course, you also have Rocket, so RKT, Rocket. You have Linux containers and you have CRI-O. So that's for containers. Let's talk about a virtual machine in more granular terms. So, virtual machines are heavy software packages that provide complete emulation of low level hardware devices like CPU, disk, and networking devices. And virtual machines may also include a complementary software stack to run on the emulated hardware. And this hardware and software packages combined produce a fully functional snapshot of a computational system. So that's important to really look at it from a storage point of view. So what are the pros and cons of let's say the virtual machines? The pros first, so you have full isolation security and interactive development. On the flip side, you have iteration speed and the storage size cost. So when you think about full isolation security, that's on the plus side. Virtual machines run in isolation as a fully standalone system. This means what? It means that virtual machines are immune to any exploit or interference from other virtual machines on a shared host. An individual virtual machine can still be hijacked by an exploit, but the exploited virtual machine will be isolated and unable to contaminate any other neighboring virtual machine. So that's important to look at it from that point of view. You also have interactive development. So containers are usually static definitions of the expected dependencies and configuration needed to run the container. So virtual machines are more dynamic and can be interactively developed. So that's kind of important to look at it from that point of view. So what happens here is that once the basic hardware definition is specified for a virtual machine, the virtual machine can be treated as a bare bones computer. What about the flip side here? Well, iteration speed. So virtual machines are time consuming to build and regenerate because they encompass a full stack system, and any modifications to a virtual machine snapshot can take significant time to regenerate and validate the behave that like they had to validate the behave as expected. You also have the storage size cost. So virtual machines can take up a lot of storage space. They can quickly grow to several gigabytes in size. This can lead to disk space shortage issues on the virtual machine's host machine. So if you think about virtual machines versus containers, let's talk about challenges in software development. And I also want to really talk a little bit about the purpose of virtual machines versus containers, okay, and also the similarities between the two. So you do have challenges in software development, big time, okay. And what happens here is that organizations typically have to deploy applications in multiple environments. For example, developing on the Linux environment and testing on Windows before releasing new features. So moving the application between environments can actually result in bugs and glitches, which lower productivity due to missed dependencies. At the same time, building and testing the application in just one environment limits actually its usefulness. Okay, let me give you a few examples. You may have to develop different versions for users with different operating systems. Your system admins must update and maintain all environments uniformly increasing development costs, and you may find it challenging to move your applications from on premises data centers to the cloud or between different cloud environments. Now, if you think about the purpose of virtual machines, historically, virtual machines technology was developed to efficiently use increasing physical hardware capacity and processing power. So, running a single application environment on a single physical server underutilized hardware resources. So, virtual machines allow organizations to install multiple operating systems and create multiple environments on the same physical machine. So, what's the purpose of containers? Well, containers were created to package and run applications in a predictable and repeatable way across multiple environments. So, instead of recreating the environment, you package the application to run on all types of physical or virtual environments. And this is kind of similar to putting an astronaut in a spacesuit instead of recreating the Earth's atmosphere for them on another planet. So, what are the similarities between the two here? So, containers and virtual machines allow for the full isolation of applications so that you can run them in multiple environments. They virtualize or abstract underlying infrastructure, so users don't have to worry about that. They also allow you to package your software infrastructure into a single file called an image file. You can use the image file to quickly set up and run your application anywhere. And in addition, you can also use software processes to manage system configurations or scale to manage thousands of applications at once. However, the role and extent of use for containers and virtual machines vary depending on where and how the application is actually deployed. So let me talk to you about the key differences between containers and virtual machines. Okay, now containers virtualize the operating system so the application can run independently on any platform. So that's really the definition I want you to pay attention to. Virtual machines go beyond that to virtualize actually physical machines so you can use your hardware resources efficiently. Let me give you some differences below. So how do they work? Container technology involves building self-sufficient software packages that perform consistently regardless of the machines they run on. Software developers create and deploy container images, which are files containing the necessary information to run the application. Container images are read-only and cannot be altered by the computer system. So that's for container technology. You also have virtual machine technology, which involves installing virtualization software on a physical server or computer. The physical computer is called the host computer, and the virtual machine is called the guest. So what happens here is that you can configure and update the guest operating system and its applications as necessary without affecting the host operating system. And so in terms of core technology, so virtual machines use hypervisors that communicate between the guest operating system and the host operating system. The hypervisor coordinates resource sharing so the virtual machine runs in isolation alongside several others on the same hardware. Containers, on the other hand, use a container engine or container runtime, and this is actually a software that acts as an intermediary agent between the containers and the operating system, providing and managing system resources that the application needs. So that's important. So in that sense, Docker is the most popular open source container engine. And you also have the size. So what happens here is that virtual machine image files are larger in size, several gigabytes, as they contain their own operating system. So increased resources mean you can duplicate, split, abstract, and emulate entire servers, databases, desktops, and networks. And container files are more lightweight, and you can measure them in megabytes. And containers only package the resources required to run a single application. So when should you use containers versus virtual machines? So you have the environment configuration, software development speed, scalability. Okay, those are the three use cases for you to really see which one to use. So when you think about environment configuration, virtual machines give developers more control over the application's environment so they can manually install system software, snapshot configuration states, and actually restore them to a previous state if required. And they are useful for ideation and experimentation or for testing different environments to improve an application's performance. So containers provide static definitions or of configurations once the best ones have been selected. You also have software development speed. So virtual machines are full stack systems and can be laborious to build and regenerate. So any modifications are time consuming to validate as you have to regenerate the environment. Containers are a better choice if you want to build, test, and release new features frequently. As they only include high level software, they are very fast to modify and iterate on. You also have scalability, so virtual machines take up more storage space and require you to provision more hardware in your on premises data centers. So switching to a cloud instances reduces cost, but migrating your entire environment brings its own challenges. So containers take up less space and are easier to scale. And more importantly, containers provide granular control on application scalability by allowing you to use microservices. And microservices are actually an architectural and organizational approach to software development where software is composed of small independent services that communicate over well defined APIs, and containers let you scale individual microservices as required. So that's really fantastic. So, what are the extras here? Basically, there are some popular virtual machine providers, and I want to share with you some of those. Number one, you have VirtualBox. So VirtualBox is a free and open source x86 architecture emulation system owned by Oracle, and VirtualBox is one of the most popular and established virtual machine platforms with an ecosystem of supplementary tools to help develop and distribute virtual machine images. You also have VMware. So VMware actually is a publicly traded company that has built its business on one of the first x86 hardware virtualization technologies. And VMware comes included with a hypervisor, which is a utility that will deploy and manage multiple virtual machines. And VMware has robust UI for managing virtual machines. And the tool is also a great enterprise virtual machine option offering support. Then you have QEMU. So QEMU actually is the most robust hardware emulation virtual machine options. It has support for any generic hardware architecture, and QEMU is a command line only utility and does not offer graphical user interface for configuration actually or execution. Okay, so this trade-off makes QEMU one of the fastest virtual machine options. So big question is which option is better for you? Well, it really depends. If you have specific hardware requirements for your project or you are developing on one hardware platform and need to target another like Windows versus Mac OS, you will need to use a virtual machine. Okay. And so most other software only requirements can be met by using containers, really. Okay. So it's all about what you really need. And you can use containers and virtual machines together. It's entirely possible to use those two in unison, although the practical use cases may be limited. A virtual machine can be created that emulates a unique hardware configuration. An operating system can then be installed within the virtual machine's hardware. So once the virtual machine is functional and boosts the operating system, a container runtime can be installed on the operating system. At this point, you will have a functional computational system with emulated hardware that you can install containers on. So That's kind of important. So, in closing, today's conversation, I spoke to you about virtual machines versus containers. I give you what the difference is between those two, the similarities, the key differences, and when to use those, so the use cases, and now the extras. Thank you so much. God bless you. I will see you next time. Until then, remember, stay marvelous.